Okay, in this video I will discuss the forms of screw thread. This is very important one. In that there are too many types of thread forms which can be grouped into two categories. First category is what? V threads. One is V thread, another one is what? Transmission thread. So it can be grouped into two categories. One is V thread, another one is transmission thread. So in this V thread, now we'll discuss what is the V thread. It is very simple in design and easy to produce. These type of threads are basically used for fastening purpose. As I already told you, the screw threads, another main function of the screw thread is what? It acts as a fastener. So in this regard, by keeping that in the mind, we will discuss the forms of the screw thread. Again, it can be used for the fastening purpose. It can be used for fastening purpose. It includes the following threads. Again, in that V thread, it is easy to design, or sorry, simple in design and easy to produce. And these type of threads are basically used for the fastening purpose. It includes the following types of the threads. It includes three types of threads. First one is what? International Organization of Standards, that is ISO metric threads, and another one is British Association, that is BA threads, and another one British Standard Whiteworth thread. British Standard Whiteworth thread. And the fourth one, another last type, American National thread, that is ANS thread. These are the different types of V threads. So we'll discuss the one by one. So first one, ISO, that is International Organization of Standards metric threads. It is an Indian standard thread. Basically it is an Indian standard thread. It is an Indian standard thread. Just I will write the profile of an ISO metric thread. So here it includes an angle of what? 60 degree. So this is the flank. The inside one, this is the root, this is the crest. This is the crest for what? Internal thread. This is crest for what? External thread. So it's angle, make an angle of what? 60 degree. It include an angle of what? 60 degree. And here from top to top we can cut as a pitch, that is a P. It's not a pitch, it is represented by a distance of P. And here from here to here it will make an equilateral triangle. Make an equilateral triangle. The distance, that is P by 4, and the height is of H by 4. From top to this one, equilateral triangle, this capital H, and above this one the distance is what? H divided by 8, and here H by 4, and the top will be again cut as a H by 8. This is 8, that is the axis of the thread. So in this one, the base of an equilateral triangle of thread is equal to what? Is equal to the pitch with the truncated crest. Here the equilateral triangle is there, it is a truncated one, it is a cutted one. You can cut it, that distance, that truncated pitch with a truncated crest, it is equal to what? Equilateral triangle of the base of an equilateral triangle of a thread. And mathematical relationship between the norm, that is major diameter. Here we have to mention the major diameter. Here we have to mention the major diameter, that is major dia, and another one effective or pitch dia, and the bottom one, that is the minor dia, as we are already discussed in the previous video. That is the minor diameter, effective diameter, and the major diameter. So minor, we can call it as a minor or core diameter, that is DC, represent what? DC, D suffix C, small d, and effective diameter D suffix M, and the major diameter only D. So in this ISO metric threads are divided into two categories. One is coarse thread, one is coarse thread and the fine thread. Coarse and the fine thread. So coarse thread are easy to cut and less likely to seize during the tightening and the more even stress distribution. So but whereas the fine threads is having it's provide a greater strength and high resistance to unscrewing. So the screw thread with a fine pitch is designated with a letter. It is screw thread with a designated with a letter M, followed by the nominal thread or nominal thread and the pitch. That is, for example, I will give the example M 16 into 1.5. So M represent what? M represented a fine pitch. The screw thread with a fine pitch, it is designated with a capital M. It is followed by the that is nominal or major diameter, that is 16 mm, and the pitch of what? 1.5 mm. That is, this is the representation of what? Representing the screw thread with a screw thread. So the pitch of the thread is coarse, then the values is omitted and the screw thread is specified as M16. If this for example, by taking this as example, if the pitch of the thread is coarse, if it is this is also one type of category in the ISO metric threads. If it is in the coarse, then its value is omitted and the screw thread is specified it as a M16. We can only, if it is coarse, we can specify it as only the M16. This is about the International Organization of Standards. It is an Indian standard. Just I will show the profile of this one. ISO metric thread. It having two categories. One is coarse and one is fine. In that coarse, it is easy to cut, less likely to seize during the tightening, and more even stress distribution. But whereas in the fine, I provide a greater strength and high resistance to unscrewing. And just I will show the screw thread with a fine pitch designated with capital M. Just I will show the example M16 into 1.5. 16 represent effective diameter and 1.5 represent the pitch. If the pitch the thread of is coarse, then the value is omitted. Then the screw thread is specified as a M16. We have to omit if it is the coarse. So this is about the International Organization of Standards metric thread. Then we will move on to the next one. So British Association thread, it is just I will show the profile. So here again we have to write like this: equilateral triangle. So all should be in the same height. While writing the figure, just I will write a rough sketch. The angle between these two is what? 47.5 degree. This is the distance P. So this type of thread, it is used for what? Small screw used in optical instrument. This is also a Viva question. So where the British Association thread, that is BA thread, is used, where it is used means it is used for small screw used in the optical instruments, clocks, etc. This type of threads are used in the optical instruments, that is small screw used in optical instruments, clocks, and etc. This is about the British Association thread. Next, the British Standard Whitworth, that is BSW, thread. It is most widely used thread section in V threads, wide section in the V threads. And the next, it is mainly employed in the machine construction, where condition favors the use of bolts, screws, and other thread pieces. So it is mainly employed in machine construction, where the condition favors the use of bolts, screws, and other thread pieces. So in this case we are using a British Standard Whitworth thread, that is BSW thread. Just I will write the profile. That height H. as I showed earlier. The distance between these two we can call as a P, and the angle is 55 degree between the threads. So height we can call as h by 6. Earlier in the previous thread, in the previous this one in the international standard of organization, above is h by 6 and below h by 4 we are done. So here it is both should be in the h by 6, and this is the internal diameter. So this is what the British standard whitework thread used for thread section in the V threads. It is mainly employed in the machine construction where the condition favors the use of bolts, screws and other thread pieces. It is also used where easy and quick assembly of the parts is required. Used where easy and quick assembly. There we are using a British standard whitework thread. And the last one, American national thread, that is ANS thread. It is considered as a standard locking form thread in USA, that is standard locking form thread in USA, that is American national thread, that is ANS thread. Just I will write to the American profile of this one. So diameter is internal diameter D, height H, that is P, F is the width of the flat, that is width of flat, that is P by 8. Okay, it is similar to the V thread, but it is flat at the bottom and the top. It is similar like that of the V threads, but it is flat at the top and the bottom. And also the strength and the locking characteristics of these threads is more, hence they are used in rough work. Where the rough work is required, there we are using the American national thread, and it helps in the strength and the locking characteristics. So in this type of we can call it as a, we can use the American national thread, that is ANS thread. The first one is what in the international standard, the international organization of standards, that is ISO metric thread, and that is second one ISO, and second one is British Association thread, that is BA, that is used for small screws in optical instrument and clock. And the third one, British standard whitework, there where they were using a V threads thread section in V threads, and machine construction and easy and quickly assembly, where easy and quick assembly is required, we are using a British standard whitework, that is BSW thread. And the last one, American national thread, that is ANS thread. Both the top and the bottom, both but the shape of the shape is similar to the V thread, but it is flat at the bottom and the top. Where the rough work is required and the strength and the locking characteristics, we can use the American national thread. It is the standard locking form thread in USA. There is this is also a Viva question, that is American national thread. So this is regarding the V thread. In the forms of thread, this is one type, that is one category, that is V thread. And in the second one, in the transmission thread, second category is what? Transmission thread. It is used to cause the displacement in mechanism. Used to cause displacement in mechanism. It is in the previous one V thread is for fastener, here to cause the displacement in mechanism. So we are using a transmission thread. Transmission word itself only mentioned that threads is also one main function. Initially I have told you the main function. It is used as a power and motion transmission. So it is used in the transmission of motion and the power. For example, lead screw of the lathe machine, screw jack thread on machine wise. These are the different types of transmission threads. So lead screw of the lathe machine and screw jack threads on machine machine wise, etc. These we can call as a what transmission of what both motion and the power. As earlier in the previous video discussing regarding the functions of the screw thread. So in this one we are having a three types of threads. First one is what square one, second is a acme, that is ACME, and the third one is what buttress thread. In the square thread, just I will write to the profile of this one. So the pitch of this is what P by 2. Just I will write to the rough sketch. So P means what one thread to another thread. P is having a very high efficiency, difficult to manufacture. It is very difficult to manufacture. This is square thread. As the thread profile is perpendicular to the axis of rotation, there is no side thrust on screw. This is very important. There is no side thrust on the screw takes place, and the last they have low strength, and even slight wear of square thread requires the screw to be replaced. This is very one of the disadvantage. It is having a low strength and even slight wear off, and even where you get a slight wear off square thread requires the screw to be replaced. This is one of the main disadvantage of this using the screw threads. Okay, then this is regarding the screw thread. Then next type acme threads. It is having a screw threads are high efficiency, are difficult to manufacture, but acme threads are high strength and load carrying capacity as compared to the screw thread. Having a load carrying capacity compared to the square thread, acme thread having a high strength and the load carrying capacity. And just I will write to the profile. So the angle is about 29 degree, and pitch is from here to here, that is P. These threads are easy to manufacture and having low efficiency. Here the square thread is easy to manufacture but having difficult to manufacture, having high efficiency. It is easy to manufacture, having low efficiency. The inclined profile of the thread result in side thrust on screw. There is no side thrust here in the square thread, but here the side thrust is there. So acme thread is a special type of here it is a special type. It is a special type of thread, trapezoidal. Special type of trapezoidal thread with a thread angle of what 29 degree. Then thread angle of 29 degree. So this is regarding the acme thread. Just I will give the difference between these two. It has high efficiency and difficult to manufacture, and here there is no side thrust. It is very low strength. Here compared to this one, it is having high strength. Load carrying compared to square thread is having it is very good high load carrying capacity. And the special type of trapezoidal thread, it is an angle of what 29 degree. Here the side thrust is there. So this is the main difference between square thread and the acme thread. And the last one, buttress thread. Just I will write the profile of this one. So from here to here the distance is 0.75 into P. From here to here, this is P. It will make an angle of what 45 degree, and distance between these two that is flat 1.125 P. So this is also having a high efficiency, as compared to the trapezoidal one. As compared to the trapezoidal one, it is having a high efficiency, and they are economical to manufacture on thread milling machine. Thread they are economical to manufacture the thread milling machine on thread milling machine, and having high strength, same like that of Acme thread. It is having a high strength and load carrying capacity, high load carrying capacity, same like that of Acme thread. The main limitation is that it can transmit motion in one direction only. This is the main limitation of this one. It can transmit motion in one direction. This is the main limitation of what? Buttress thread. This is the main difference between square thread, Acme thread, and the buttress. These are three different types of transmission thread, where the transmission thread is used for transmitting the motion and the power. To cause the displacement in mechanism, we are using a transmission thread. In that, we are having three types, that is square, Acme, and buttress. It is high efficiency, difficult to manufacture, no thread, low strength, and slight wear of the square thread requires the screw to be replaced. This is the main limitation. In the Acme thread, high strength, high load carrying capacity, then a special type of trapezoidal thread, and the thread angle of what? 29°, and the butt thread is the same like that of Acme, but here the transmission motion is only in the one direction. This is the main limitation of the buttress thread. Okay, thank you. In the next video, we'll discuss the measurement of major diameter and the minor diameter. Thank you.